Miles is currently the Program Director of Industrial Design here. He has also been a very successful designer in consultancy work, including firms which have involved him, Design Resource, Design Edge, X-Pace and MPID. He's contributed in effect to many commercially successful products and continues to combine design practice with design thinking and teaching. I welcome you to Miles now. Thank you.
Thank you very much, Ali. Tonight I wanted to present to you a close-up look at the built environment, and that is at product level. I mean, this series has been based upon acknowledgements of heritage, whether it's landscape building, and tonight we're going to look at heritage of products. It's a story that involves an extraordinary themes of waste as well as opportunities. There's a Lehman banker involved, as well as it's talking about the intertwined history of industrial design and obsolescence. We're going to look at some of the background in terms of how these twin things emerged. There's Cuban and Russian tinkerers, American hackers, rappers and mountain bikes. So a bit of a mixed bag. So the short lifespan for many consumer electronic products remains a relatively unattended dimension of the e-waste problem. Products normally described as consumer durables are now often regarded as consumables. The lifespan for many consumer electronics, notably personal computers and mobile phones, are getting shorter. There are many factors that contribute to obsolescence in the consumer electronics sector. Technological change is a major cause. With unprecedented growth in the consumption of technological devices, along with diminished operational lifespans, often now measured in months and not years, for many products it is unsurprising that the volume of e-waste has significantly increased. So this presentation is based upon a chapter from a book called Longer Lasting Products, and it's edited by a colleague of mine in the UK, and they'll be coming out shortly. But the way I wanted to present tonight's presentation was based upon looking at three parts. First is about quantifying the problem, or quantifying e-waste. Next is about conceiving obsolescence, and that we're going to take a little journey in looking at the history of industrial design. And the final component is looking at defying obsolescence. What can we learn and how can we design out obsolescence? So each year approximately 17 million televisions and computer-related products reach the end of their life. Last year we bought 2.4 million new computers while sending 1.6 old ones to landfill. In addition, 800,000 computers are put into storage. The electronic waste, or e-waste, is growing at 3 times the rate of any other category of municipal waste. So there's some numbers to try and get your head around. And I'm sure this is a familiar sight that many of you have seen on a verge nearby. So why is it different from other types of waste? The DNA of consumer electronics, with their complex inventory of components, sub-assemblies and material alloys, results in a significant environmental impact far greater than many other categories of waste. The manufacture of consumer electronics is energy intensive, we know that. The consumption phase brings other impacts such as CO2 emissions associated with electricity to drive these devices. But further problems arise when products reach the end of life. When these products enter the waste stream, potentially toxic and valuable materials are lost in landfill, or more alarmingly, incinerated. As this hardware breaks down over time, dangerous toxins leach, or leachate as it's referred to, leach into the groundwater, contaminating soil, waterways and ultimately our food chain. A standard cathode ray tube, CRT monitor, the older type with the long tube, contains more than 2 kilograms of lead. The toxicity of lead is well known for centuries, with children particularly susceptible to its effects. Other toxins contained within e-waste include mercury, phosphor, barium, cadmium, chromium, beryllium, and another one which we'll hear more about, I'm sure, in coming years is bromated flame retardants. So the regulation framework is well advanced in some countries in regulating e-waste, end-of-life electronics, notably United Kingdom, I should say the EU, Japan and Taiwan. But for non-OECD countries and the developing world, regulations, if they do exist, are rarely enforced. And we're looking at here at a Greenpeace video which was released a few years ago, just showing the kind of process for recovery of these quite valuable materials. So where is all this stuff coming from? Well, over the last 20 years or so, electronics have migrated into new product areas that traditionally have been populated by manual or mechanical devices, including kitchen appliances, bread makers, electronic pepper mills and so forth. We're seeing also with other devices such as in children's toys, novelty, fashion, low-cost features are increasingly evident in these type of products. Some of the more bizarre examples include things like vibrating soap or battery illuminated sweets. This vibrating soap consists of a motor and battery assembly within the cake of soap. Lighting bugs is a battery illuminated confectionery, consists of a pair of disposable tongs containing a battery and LED, light emitting diode, which glow when you pick up the translucent lolly. The functional lifespan of this throwaway device is only as long as it takes to eat a packet of sweets. Another driver is a deflationary factor, and this has got to do with purchasing cost. Purchasing cost is probably the single most important factor in determining product lifespans. The electronics sector has been subject to incessant price erosion over many years. And this graphic, although old, is telling in that it shows the contrast between the time or how long it takes to earn in standard wages the various commodities. So for instance, a television in 1962, an average worker would have had to work for 44 days, whereas in 2000 it's dropped to 2.5 days. And I suspect the statistics now would be less than that, although with newer technologies that we're seeing hitting the market now, perhaps that's skewed somewhat with the digital switch and new flat screen technologies. Another dimension is costs. So cost impacts upon product lifespan extend much further than just the purchasing price. The ratio between cost and repair has dramatically reversed in recent years. A Scandinavian study found over a 10-year period the cost work for a television and a washing machine increased by 150% and 165% respectively. Meanwhile, products such as consumer computer printers that are highly dependent upon consumables, i.e. their consumable inks, are often priced artificially low to lock in users into expensive consumables. So situations arise where the durable component of the system, i.e. the printer, costs less than actually the consumables. And here we've got a recent ad which shows that the replacement inks will cost you $67.87 as opposed to the purchase price of the printer, which is only $57. And we see the same crazy pricing schemes happen with DVD players. The DVD player is cheap, but the Hollywood blockbuster film you want to buy actually will cost more than the actual player that it works on. So in some ways we could say, well, this has been great. It's democratised consumption. So these deflationary price trends have brought new material benefits to those who previously could not afford such luxuries. So we have a situation where it's not just keeping up with the Joneses, but with the Kumas and the Wongs. But the downside is that the developing world are increasing their contribution to this total in e-waste. They are expected to triple their output in the last 4 years. So, points of view. We could say, well, the exponential growth is good. I mean, the consumer electronics, manufacturing and retail sectors obviously would see it in that way. To many other groups, notably non-government organisations and academic researchers, such growth presents notable problems, social, environmental and economic. So what is being done to tackle this complex and growing global problem? What has been the role of the various stakeholders, including designers and the consumer? So rethinking e-waste. If we look at the typical makeup of a consumer device, such as a phone, it's got many valuable materials within it: copper, aluminium, steel, gold, nickel, tin, etc. So there are advantages in thinking about, well, if this product's reaching end of life, what can be done to recover it? This is a quote that was in Tuesday's Business Press, and I think it's quite revealing. Robert Phelan, who's the boss of the Canadian mining company, Ivanhoe, stated that the world will need to mine an extra 600 million tonnes of copper in the next 20 years to keep up with demand. And he's quoted here in the paper on Tuesday saying, frankly, those of us in the business have no idea where this metal is actually going to come from, he told delegates at a conference on Tuesday. Well, I'm no miner, but I might have an answer for him. If we look at nature, the waste from one plant becomes, or animal, becomes a resource for another in a symbiotic, self-regulating relationship. If we apply the same concept to a closed-loop industrial ecology, it could offer significant advantages and opportunities for the economy and the environment. So the equation here is waste equals food. Now we can see here that copper prices have spiked in recent times, apart from a little blip where we had the financial crisis in 2008-9. And so if we look at the price of copper, it starts to suggest that there's got to be other ways of dealing with e-waste. And indeed, again, looking at a streetscape, not unfamiliar to many of us when the council had their pickup, if we go a little closer, we'll note that this television has been tampered with. Recyclers, unregulated recyclers, have come around, and what they've done is they've lifted the yoke off the television. The yoke being a dense assemblage of copper wire. Unfortunately, they leave the product in ruin like this, which has got health and safety implications, as well as absolutely no value to the regulated e-waste recyclers. So, waste equals food. Perhaps we should be formalising this urban mining approach. If we look at gold ore yields, we know that mines are usually regulated about 5 grams per tonne of yield in terms of gold. But if we look at consumer electronics, the yield is significantly higher. So there's got to be a business opportunity when you look at those numbers. 300 grams per tonne in gold ore for phones. However, this is not without challenges. We have problems with contamination, security of supply, transport costs. We need to subsidise the processing of the worthless materials in these products. These materials exist in complex matrices within the product itself, which are difficult to get at. And at best, some industry experts say that at best we can get 34% recovery of these materials out of e-waste. So there are some challenges. Just in terms of the legislative framework, the EU, for instance, has a directive for its member states referred to as the WE Directive, Waste Electrical and Electronic Equipment. In Australia, we have obligations under the Basel Convention on the control of transboundary movements of hazardous wastes and their disposal. In other words, the import-export of e-waste. We also are signatories to the Stockholm Convention on Persistent Organic Pollutants, of which brominated flame retardants are one. And we have an emerging environment where we have a national waste policy. Product Stewardship Australia is an industry body representing manufacturers and retailers, and they've been working with government and other stakeholders in a co-regulatory environment about dealing with the take-back of electronic waste. This is pending implementation in 2011 based upon bipartisan parliamentary agreement. Fingers crossed. The idea is that this scheme will roll out first to look at the compulsory take-back of televisions, and then it'll be rolling out to other sectors in future. But there are many challenges faced within this scheme, is that who pays for what, the transparency, there's tracking, what about the freeloaders, the grey importers. We need to get some government harmonisation in regulations in terms of importing toxic waste from non-OECD countries and so forth. So the policy environment is there, but there's many challenges ahead. One of the things that the policy advice often talks about is design, and this is curious because I wonder who they're talking to. They say that products should be easier to disassemble, and in industrial design we often refer to this as design for disassembly, which has been a part of the eco-design toolbox for a number of years now. They also talk about more durable products, which suggests that products should be lasting longer. But I put forward the idea, are we designing products that last longer, or are we simply designing more durable waste? Over 90% of computers and mobile phone equipment is still functioning when it's disposed of. So this suggests that durability isn't necessarily the problem. So are we simply designing more durable waste? Part two, what I wanted to do here was to look at some of the background in how obsolescence is conceived. And I think this might go part of the way to understanding about this question about why isn't durability the main figure in this idea of obsolescence. Tim Cooper, an expert in the field on product lifespans, refers to the typology of obsolescence, and it's a matter of mind, money and matter. And it's often described in the literature as there's absolute obsolescence or relative obsolescence. So absolute obsolescence is characterised, I've got that the wrong way around. There we go. I'll let you do a mental flip and all that. Absolute obsolescence is about the functional operational durability. So if something breaks down, it breaks down absolutely, okay? So that's the kind of durability aspect of the obsolescence typology. Relative obsolescence, on the other hand, is about the psychological, economic and technological factors. It's relative to how products get used and consumed. And this is the interesting aspect of the obsolescence equation. So we need to look at something in terms of the psychology, the psychological and most social motivations that lie behind the many facets of relative obsolescence. Tim Jackson, who's the author of a recent book called Prosperity Without Growth, refers to creative destruction in our quest for new and novel goods. In the pursuit of identity, status and meaning, the challenge of the throwaway culture is not just a technical one, it's not even simply an economic one. What links expanding production to the relentless consumption is our apparently voracious appetite for novelty. Okay? The sociologist Colin Campbell talks about, while technological innovation and planned obsolescence both have a part to play in keeping consumption levels high, the greatest contribution is consumers' almost magical ability to produce new wants immediately after old ones have been satisfied. So it's the playing with our minds, it's the social construction that, and the way we use and consume, and the way we use products as positional goods to sort of note stuff about our social status and so forth, and hence the saying, keeping up with the Joneses in terms of your consumption practices. So I've briefly mentioned absolute and relative obsolescence. There's one other type of obsolescence that I'd like to introduce, and this is ecological obsolescence. And this is a new form of obsolescence that's emerged in recent times. It's based on the logic that it's better to retire an old, inefficient product for new, efficient ones. One study concluded that the optimum lifespan for a dishwasher is 8.1 years. Got that? 0.1, very important. After which it's environmentally beneficial to replace it with a more technologically advanced, eco-efficient model. That makes good sense. So in purely technological terms, eco-optimization, after 8.1 years, through obsolescence, may be able to determine the appropriate lifespan. However, when other factors are accounted for, including actual consumer behaviour, the way products are really used, as well as the way those products change our behaviour, and I'll talk a bit about that in a moment, lifetime optimisation calculations may present an incomplete or misleading picture of environmental loads. Just to add another dimension to this whole question of the way we consume and our behaviour, if we look at the typical appliances owned within a household, this is UK statistics, it shows that a remarkable increase in the amount of products we have within our homes. So energy efficiency in the UK domestic household appliance market is claimed to have improved 2% per year since 1970. So 2% a year, products are getting more efficient. However, total energy consumption by households has doubled. So this diagram here might go some way to explaining that we have more products populating our homes. So it's the cumulative effects of consumptions that are starting to play here. And we could say here that we have demand overriding efficiency. And this is another theme I just wanted to touch on. So we have demand overriding efficiency. Efficiency can change behaviour, and then behaviour changes the efficiency. So when we replace an old appliance with a more efficient one, this can change the way we use them. To illustrate one scenario, a new efficient washing machine may consume only 0.3 of a kilowatt of electricity per wash, compared with an older machine which might use a whole kilowatt hour of electricity. So based on 270 cycles, typical for a UK home, this would represent a saving of £8 per year. If the older, less efficient machine is used only intermittently, over an extended period, it would make little sense to upgrade to the more environmentally efficient machine. So, in other words, if you're using the modern eco-efficient machine 275 times a year, as opposed to your older machine, which you might only use once a week, you get a very different outcome in terms of the energy loads of that appliance over a period of time. We could look at television and car usage patterns in the same way. Now, economists refer to this as a rebound effect. So improved product efficiency can backfire and encourage a change of behaviour. So these rebound effects are significantly important but very difficult to quantify. So the rebound occurs when the designed-in energy and material efficiencies of a product result in an actual increase in resource use. And so this is an area which I think much more research needs to be done, and an area which I think has a significant contribution to make to the emerging and persistent desires for more efficient products and the consumption of those products. Just going back now in terms of a bit of history, obsolescence first appeared back in the 1920s at the same time of the Great Depression. And we had a publication called Selling Mrs. Consumer, where we first had the terminology arise. And here we have terms such as progressive obsolescence. And the idea here is about human satisfactions through the purchase of more goods should be encouraged. Bernard London, who produced a pamphlet called Planned Obsolescence, Ending the Depression with Planned Obsolescence, talked about getting the government to assign the lease of life on things. So things had a predetermined lifespan. And this is where the theme of industrial design starts to come into, because following the stock market crash of '29 and the ensuing devastation of economic depression that followed, intensive competition that led manufacturers to adopt increasingly sophisticated sales tactics to boost sales. Income from manufacturing had contracted by 2/3 between 1929 and 1932. It's around this time that the first generation of consultant designers, Raymond Loewy, Walter Dorman Teague, Henry Dreyfus, established their design practices. Initially, they had little success, but soon rose to prominence. The key to their success was through product styling, which was adopted by manufacturers as a means of making their products distinctive from their competitors. Along with advertising, celebrity product endorsements, and the newly devised purchase on credit schemes, styling represented a key role in the arsenal of increasingly sophisticated marketing strategies adopted by manufacturers to lift sales. One particular style that captured designers in the public's imagination was streamlining. And it was influenced by the scientific and technological advances of the day. Even stationary objects such as refrigerators, toasters, pencil sharpeners and vacuum cleaners were designed in the streamlined style despite their dubious requirements for aerodynamic efficiency. Streamlining was seen by its proponents as a metaphor for consumption, enabling the flow of a river of goods by reducing the parasitic drag or its counterpart, overcoming psychological drag of consumers who refused to give up their old products for new. In other words, it was good for business as it reduced consumers' resistance and led to increased sales. However, it was not until after World War II that obsolescence became more widely practiced as a stylistic device by designers and marketeers. And just as a counter-trend which emerged during World War II in Europe, government austerity measures in Britain, encapsulated in the catchphrase "make, do and mend," galvanised a nation to stockpiling items to provide vital parts and materials to repair worn-out clothing and household goods. However, with post-war economic recovery and the subsequent dramatic rise in consumerism, manufacturing industries and the discussion of obsolescence reappeared. This time round, as it remains today, it was a much more contentious issue. In a brochure in 1953, the American industrial designer Brooks Stevens proclaimed that the great strides of industrial design are yet to come through planned obsolescence. Within a few years, he perfected his definition of what he called planned obsolescence. And at one documented gathering of advertising executives, he stated that by deliberately building in planning obsolescence, a struggling economy could be reinvigorated. And here we have another one of his catchphrases about instilling in the buyer the desire to own something a little newer a little better, a little sooner than necessary. And I just include this slide out of curiosity because it's it's very of its time. But the remarkable thing is that the car in the foreground isn't a full-size car. It's a 1/8 model. It's been very carefully photographed with Eero Sanninen's building in the background to give it that gravitas of modernism in which it was conceived. However, Brooks Stevens wasn't on his own. He was attacked viciously by people such as Vance Packard, who gave planned obsolescence its first popular outing. So he produced a book called The Wastemakers, where he dissected obsolescence and talked about functional obsolescence, quality obsolescence, and desirability obsolescence. In the meantime, he popularised another catchphrase, the throwaway society. And he stressed the importance of how consumer psychology shaped the way we perceive a product and our consumption practices. Even within the US design fraternity, the idea of planned obsolescence was controversial. A founding figure of industrial design, Walter Darwin Teague, led the charge and was quite an outspoken critic of Stevens. And later, Victor Pasternak went on to further his condemnation of the profession in terms of its damage it was doing to the environment and not meeting real needs. Now, the third part of the presentation is about looking at the ways obsolescence can be defined. And this is drawn particularly from the chapter in a book, forthcoming book, as well as the topic of my PhD research. How are we going for time, Alec? Terrific, okay. So in the face of the many forces that drive obsolescence and the throwaway society, there are examples of products, behaviours, and societal factors that defy obsolescence. Many of these are informal or unplanned and have evolved due to particular situations or individual circumstances. However, the slide before you here illustrates how long life can be a marketed attribute for your product, and Volkswagen have leveraged this idea for many years through their advertising. So let's just look at product examples and in terms of product life. So plastic and polished surfaces are one area which are very prone to surface scratching. So plastics in particular, one class of material closely associated with consumer electronics and indeed industrial design, offer a range of qualities and performances unrivaled by any other materials. However, they have a number of persistent shortcomings, including the perception they are often an inferior substitute for other more quality materials. When discarded, the slow degradation of plastic-produced products can have a detrimental impact. Indeed, degradation often starts well before the product's discarded, as the ageing of plastics results in the aesthetic and functional performance degradation in the form of loss of clarity, crazing, cracking, warping, dusting, colour bleaching, or indeed yellowing, where products are exposed to ultraviolet light. So aesthetic degradation of products can also be accelerated by poor product design. Spray painted, polished or smooth surface finishes, crisp edges are common on many portable consumer products, such as laptops, mobile phones and digital cameras. These and similar finishes are prone to a highly visible form of aesthetic degradation. The use of generous edge radii, uniform polymer pigmentation rather than surface finishes, and textured rather than smooth surfaces are just three simple practical measures that can slow the aesthetic degradation of a product. Contrastingly, in some circumstances, marks and scratches that a product acquires in its lifetime can become a desirable feature, such as the patina on antique furniture, a well-worn leather belt or a wooden handle. However, we are much less tolerant of patina on electronic products, and perhaps for good reason, as such markings often indicate misuse or misadventure, although not all marks need to be condemned this way. Wear on so-called semi-professional equipment can be advantageous by linking the aspirations of the amateur consumer to professional usage of the product. For example, through material selection, surface texture and detail, Bosch cordless drill range communicates a message about toughness and DIY aspirations. Bosch further reinforced this distinction between professional and consumer markets by colour coding green for domestic consumers and blue-green or teal for professional users. The logic of this carefully marketed good presupposes that professional equipment is manufactured to a higher specification than an ordinary product to take the knocks and abuse of daily professional work. Okay, so that's a product level aspect. Here's another one, upgradeability. This is a pretty straightforward concept to understand. And so if we can replace certain parts, either hardware or software, to keep up with the latest technology and enhance functionality, products are more able to avoid obsolescence. So when to decide to upgrade a product or not is less clear for many types of products. One approach that may address this kind of problem is scripting. Okay, this is a process that weaves product design and user psychology. In a film or a play, the role of the script is central to defining actors' dialogue and actions. Similarly, a designer may devise a script for a product that seeks to define a role for the user to play. So here we have a coffee cup, and the coffee cup illustrates this. A ceramic mug is inscribed with a script of reuse, while a foam or paper cup is inscribed with an opposing script of disposal after use. So it's an obsolescence script, we could say, within a paper coffee cup. So the material used in making the coffee cup are inscribed with the value that is expressed as a narrative of how we are to organise such products around our daily lives. Other products may contain a maintenance script. For example, leather shoes require the periodic application of polish to restore their finish. However, most shoes don't come with instructions in terms of the maintenance procedure. It's culturally inscribed within the materials of the product. So here is a lead. Can we culturally inscribe within, say, short-term lifespan products such as consumer electronics, a script which says something about prolonging product lifespan? Tinkering. Tinkering is a means to resurrect a product from the dead or modify it to perform new tasks, and can provide a great sense of satisfaction and achievement. Many household products that have failed or shown signs of wear can be repaired or refurbished with fairly basic knowledge of product construction, materials, mechanism or electronics. Those that are easily to disassemble or consist of relatively simple mechanisms are the most obvious candidates for tinkering. However, many factors conspire to discourage it, including an increase in sealed subassembly units, the use of tamper-proof or hidden fasteners, and warning labels stating that warranty will be voided if the product is tampered with, or no serviceable parts inside. So many small products, such as hairdryers, toasters, food processors, fall into this category. Failure of any one component can terminate their lifespan immediately. And this slide here just shows a little kit you can buy for your iPod. It actually comes with a pair of special little tools for prying open the actual product itself so you can replace the battery. Of course, it makes the disclaimer is that you void your warranty and any responsibility is your own, but it's a widely accepted means for repairing iPods. Another means that products can defy obsolescence is this idea of design classics. So, such an appellation can be achieved through the reputation of a designer. It could be critical acclaim, it could be cultural significance, scarcity or market value. Design classics often attain high prices when traded and are keenly sought after by collectors. However, the term design classic is problematic and has been devalued through its arbitrary overuse in contemporary culture. Products that are often marketed as design classic, even though their long-term survival, reputation and significance is highly speculative. But there definitely is a story there to be told about the significance of products that attain this accolade as a classic, often have long life. One retail company that tries to negotiate such concerns is a German firm called Manufacturing, which claims that many of its items in its mail order catalogue are classics that have stood the test of time and will outlive any trend or fashion. Manufacturing markets its products in terms of both functional and fashion durability. This includes tangible and intangible aspects of the product, from the physical quality of the manufacturer to abstract values that touch on emotional, traditional and cultural significance. The company's catalogue emphasises the relationship between designer, producer, distributor and the customer by telling a backstory of the product, highlighting its provenance of design, its manufacture and stories from satisfied users. A societal or market force that can be implicated, market forces clearly can be implicated as a central cause of obsolescence. But certain markets offer a means to extend product lifespans. Secondary markets such as auctions, classified advertisements, etc. offer a range of opportunities to extend the product life. Products no wanted or needed by one owner can be sold or donated or traded to another new owner. On websites such as eBay, FreeCycle, People Trade Exchange donate products. eBay in particular has been enormously successful in popularising the trade of second-hand goods, with 181 million registered users worldwide and 3 million items listed at any one time. Another possibility for extending product life could be what's referred in sustainable design circles as product service systems. And a product service system is about where you offer the potential to replace the physical ownership of a product by offering a service-based solution to customers, emphasising meeting their needs rather than selling them physical ownership. So we have many examples of this emerging now. Probably the most traditional example is in the business-to-business environment with the leasing of photocopiers or business equipment. But we're seeing it now with things like car share schemes emerging in many cities around the world. So such an approach requires a different business and social arrangements. And leasing is already well established, as I said, in many fields. But in such instances, lifespan is probably more meaningfully measured in service life. In other words, how intensely is the product used as opposed to how many years of ownership, which seems like a fair trade-off. Products in certain circumstances can be transformed or reassigned from their original function and purpose into something entirely new, undreamt of by the original designer or manufacturer. Product reassignment or repurposing is a reconfiguration of an entire product through software or physical adjustments that enable it to perform entirely new tasks. It often arises in circumstances of necessity. So in Cuba, for instance, examples exist of products being reassigned to perform new tasks, such as here we have a squeaky toy as a bike bell, and we have a old Soviet fan combined with a telephone to make a desk fan. Or here we have a direct immersion heater. Plug it into the live power and drop this into your saucepan as a kettle. Or a plastic container illuminated as the taxi sign. And there are many examples in the developing world of these sorts of instances. I particularly like this one here. This is a Russian folk art example, and it's an improvised product which is a television aerial, obviously to receive signals from those capitalists on the other side of the border. Mind you, this is 1980s we're talking here when this product was conceived. And it's fabricated out of kitchen forks, as you can see. But indeed, there's a wonderful world full of these creative solutions born out of necessity. And indeed, in our own country or developed world, there's many examples where leisure time can be taken up with challenges of tinkering, turning a broken stereo, in this case, into a new configuration of that product. So how can we take some of these informal practices about defying obsolescence and look at how they could perhaps be formalised within a design process to look at product life? So here are two projects that were undertaken as a part of my PhD work, and they were attempted to illustrate how you could take some of these concepts, in which case the first one is about reassignment, and look at the reassignment of a mobile phone into a new device. Now indeed, Nokia had been looking at these sorts of projects a few years ago, where they were experimenting with this concept of mobile phones being turned into things like alarm clocks, handheld games devices, or even television remote controls. So this product here, PIST, is a plug-in module that enables specific types of mobile phone, smartphone technology, to be reassigned into an alcoholic breathalyzer. This is achieved by utilising the existing assets found within the phone, such as battery, screen, CPU, keyboard and speaker. When the breathalyzer unit is plugged into the phone, it reconfigures the phone's operating system to function as a breathalyzer. So both devices are complementary to each other. And here we are in action. Another project was piggybacking. And piggybacking could be described as enabling renewed or enhanced functionality in a technologically obsolete product through the addition of an add-on secondary device. So we're piggybacking one device onto the other. In this instance here, what we're doing is we're looking at a device which enables digital audio to be received by existing analogue radios. So the product piggybacks onto the existing aerial. It then receives the digital signal, which rebroadcasts back into the radio as an FM signal. So it's analogous to the set-top box that some of us might have with our televisions. Despite the many obstacles devised by manufacturers, tinkering remains a widespread practice activity. Practitioners benefit from several magazines, including Make magazine, who have this wonderful phrase, if you can't open it, you don't own it. And they have been immensely successful in capturing a whole community of people who are interested in it. And they have created workshops which they call hack spaces, and they're popping up all over the world. There's 124 hack spaces in the US, 13 last count in Australia. A company that regular advertises within their magazine expects sales in excess of $10 million this year. They have an annual Makers Fair which they hold in California. It attracted 75,000 people to it last year. So there's a whole lot of interest in this idea about repurposing, reconfiguring, hacking, tinkering with products. However, if we go a little bit deeper, there's much more to this story than the odd person tinkering away. Today's tinkerers are involved in a distributed network of collaborative innovation. Ideas are freely exchanged by mutual interests supported by the availability of new and affordable technologies. So some notable thinkers have written about this, people even as diverse as Alvin Toffler, Tim O'Reilly and Charles Leadbeater. And Charles Leadbeater reminds us that this phenomenal, the phenomenon of success of mountain biking and rap music, and indeed open source astronomy, are all down to the work of amateurs working in a loose collaborative project that is not defined by any design brief, project aims, objectives or performance specifications. He uses the term PROAMs. He offers us some qualities of this sort of collaborative innovation, this open source environment in which innovation is happening, where he's saying that the consumers are the innovators and that it's all bottom up, not top down. So looking at concluding, many of these tastes which I've tried to offer you in terms of this, what I think is an interesting range of opportunities for designing out obsolescence, is that until we reach a time where e-waste is effectively and efficiently recaptured in a closed loop to be redeployed into high-tech manufacturing streams, there remains an urgent need to go against the trend for shorter lifespans. Technological change, market systems that currently conspire to promote obsolescence can be harnessed to prolong lifespans. Similarly, specific individual behaviours can be a model for wider social change. So the examples here offer opportunities to develop, formalise and incorporate change in design business practices that could have profound effect on the way we acquire, consume and discard products. So design needs to play a more active role in understanding the way we use, acquire and consume products. Okay? So product value doesn't just come from the designer. It need to understand how that product value can be built up over the time in terms of the user's contribution. So it's going to require a shift. So the design process needs to be revealed and inclusive to the user as a co-designer of products in a continuum throughout their lifespan. The open source movement, user-generated content providers that increasingly populate the internet offer a model of how this could be achieved. Such an adaptive product approach will require designers to create products that are intentionally unfinished or open. This would offer the user the opportunity to become a co-producer in a continual process of product reconfiguration. So the role of the designer is still primary, but we now delegate a role for the user in a sort of two-way traffic to mediate this journey through a product's lifespan. And there's a lot to be learnt from the online environments used, as I've said. So obsolescence in the consumer electronics sector is unique in its scale and growth, and overcoming it requires strong leadership from government, industry, and a shift in consumer attitudes and behaviour. Design needs to play a role, a much more active role in understanding the way we acquire, consume and discard products. Much can be learnt from existing products. By understanding product qualities, individual behaviours, socio-economic contexts, designers can become better equipped to design longer life products that redefine e-waste. So waste is not as waste, but waste as a resource for industry and an opportunity for individuals and collaborative innovation. And just to finish, to say that there's a book that will be released next month that explores this and many other themes that I've contributed to. And as I say, it has been a neglected aspect of the whole waste cycle, and indeed the whole question about e-waste. So thank you.
Fantastic. Excellent. We've got time for a few questions. I have one. Start. I like well-designed products, and I like them to last. I like to keep them. And I grew up with a sort of, I believe, a Raymond Loewy, that's how you pronounce it, Formica designed kitchen table. Oh. And the Formicas seem to be indestructible. And I did do some work for CSR panels, which include the Formica range. And I didn't quite get to the bottom of this, but there was a possibility you could manufacture all the resins and so on Formica to be far more durable than they were choosing to do. It suited the economic cycle to actually build in obsolescence effectively by being degraded. And also when I changed a kitchen appliance once, a series of appliances, I had a 20-year-old German washing machine where the new version of it, they said, would not last as long as the old version. So do you know if it's true that the industry really builds in lower quality products today to speed up the economic consumer sort of cycle?
Yes.
Is that been diagnosed? I mean, can you pin a company down that produces Formica and prove that they're doing it, they can do it far better than they do because they prefer to actually have the product destroy itself, and similarly with the washing machine? Or is it just a myth?
I think there's partial truth in it, and you can do it. I mean, in terms of the manufacturing specification, you obviously work out where your market price point is and design to that price point. So that may mean that certain aspects of quality have to be compromised to meet that price point. But they're also mindful that sometimes these products may not be desired to last that long anyway, because let's say with kitchens, we know there's a churn within the way people remodel their kitchens over a number of years, and that churn might actually occur before natural wear and tear start to take a significant hold. Just back to the Formica example, there's been some interesting work done at looking at the wearing surfaces. So people have been looking at how you can actually create layered surfaces, so as they wear, they start to reveal new patination and new qualities that weren't there originally, which is an interesting approach because you're playing with the problem and making it desirable. A bit like the patina of an old piece of furniture, it takes on some new qualities, you know, as over the years. I'm not aware that any companies actually marketed products off the back of that, but it certainly seems to me to be an intriguing possibility, and perhaps that's a bit too adventurous for many manufacturers to take that idea on board.
So it ages and you like it more?
Yeah, precisely, yes. Yeah.
Why does the price point of electrical equipment dropped down so much when wages have gone up? And I illustrate that because the original equipment we bought in terms of Panasonic microwave, 1987, I think I paid something like $389. I only recently bought one, and I can assure you that Panasonic survived until 2 years ago. And I paid $189 for a Panasonic.
Yeah.
Why was I paying so much less? And the same with the video. The first video machine we had was $489. And the same with the fridges. I bought a Fisher & Paykel for over $1,299, quite a small one, and yet I noticed a much larger one advertised on the weekend for only $1,029. The wages have increased. Why?
Yeah, it's amazing, isn't it? And I mean, there's probably a number of factors there. One, of course, is a lot of manufacturing has moved to very low cost or low labour cost bases. So hence, in recent times it's been China, but even China now, labour is becoming squeezed, so companies are looking at even cheaper cost bases where they can locate their production. Economies of scale. We have a truly globalised trade now in these sort of consumer durables. When you first bought that refrigerator, you probably found that might have been built out at Silverwater. Now there's little chance of that. Perhaps there's a warehouse out there that's got some spare parts for it if you're lucky, but there won't be much else. So economies of scale, the technologies themselves, the television sets, for instance, the technology in a flat screen panel, a regular garden variety one, not one of these super duper 3D oversized monstrosities, but the normal garden variety flat screen technology can be produced now cheap as chips. In fact, that's what it is. It is a silicon chip, whereas the older ones were a glass blowing, with complex circuitry. Often some of that circuitry had to have required a lot of hand finishing, hand assembly. Much of that has been automated now. Consumer electronics, the way products are now run by software, their programmed chipsets and so forth, that dramatically has decreased the cost of manufacture, dramatically. And we should celebrate that. But of course with that comes all the other bad things about overconsumption, short lifespans, and treating these products as consumables and not as durables.
I know that it's quite popular in some parts of Europe, particularly Germany, to design products that can be disassembled and parts replaced. But I don't think I've seen anything sold in a shop here in Australia that actually advertises that they will replace parts, or that you can replace parts if they fail. Do you know if that's something that's projected to occur in the near future here in Australia?
With this this legislation, this product stewardship legislation, product stewardship meaning that the company, either the producer, distributor, retailer, take a responsibility for the recovery of the product at the end of life. It actually doesn't really discuss maintenance, repair, and that's a missing component. Yeah, I mean, if a product is difficult to repair, by default it probably is difficult to disassemble. That's probably the nature of the way it's emerged. Products are, I mean, it's very hard to generalise. Some products are just very difficult to take apart, others not so.
Yeah. But do we actually import any of these disassemblable products?
Are you talking about consumer
things like
appliances?
electric kettles and toasters, and just kind of. No, I'm not talking about Wi-Fi and food and all that.
Yeah, well, yes. I mean, in terms of the availability, I mean, if we're talking about German appliances, I mean, most of those would be on the Australian market, and I use the example of Bosch, which I think is a Swiss company, not German. They, for many years, have had a policy of maintaining spare parts and a repair, and even a take-back scheme, which they introduced back 20 years ago, well before any other country or company had considered that. Of course, there's not much point someone sending a broken Bosch drill in Australia back to Switzerland. It kind of doesn't quite make sense, but in principle it should occur. So therefore, I would say by default, the companies that from Germany who are probably selling probably more at the premium end of the market, they will probably have a much more robust system of supply of spare parts for a sustained sequence of models, could reach back 20 years or so, as well as their products are much more serviceable, I imagine.
Question really, I accept what you're talking about, building in design for longevity, but do you think the way that our economic system, our business system works, where do we take into account the full costs of a product in the whole life costs of the product? Do you think we do that well or not?
No, I think we do it terribly. I mean, the big argument, of course, is about things like climate change, and how do you have this externality of the environment, and how do you bring that into the economic model, and how do you actually price that, and the discussions about that. So yeah, it sits right outside, and then we have depreciation regimes within businesses, which discourages turnover. And I think, what is a laptop? You can write 100% off on a laptop. Is it 12 months or 2 years? So those things actively discourage holding on to products. Even down to organisations. I don't know if UNSW is one, but where when products are written off, depreciated 100%, they can't even give them away to willing students or other people, because that product has been devalued. So by principle, it has to go straight into a waste stream. You can't find another life, because that has been determined that doesn't meet the policy requirements in which that depreciation schedule has been arranged.
We have one here and one up there.
Okay. Just on our recycling industry and how well it's set up, because there's one municipality I know where you've got to split your recycling waste into metal, glass, plastic and paper. And then there's another one where you put it all in together and they're supposed to sort it out. Then there's another one I'm familiar with further down south where they ostensibly recycle, but people who work on the council tell me that it all goes into the same landfill anyway because it's too expensive to separate it out and transport it from country New South Wales to an industry that can do it.
Yeah.
So are we really set up, or is a lot of this just shadow play on recycling?
Well, I think it's falling into place, and one of the things I think will really make the change is if we look at commodity prices. You know, I've shown some of those metal, like copper, for instance, and we might see this also happen with plastic polymers, where we can start to create markets for it. Then that'll be the big change. Poor old councils, though. I mean, you know, why have we put them in the business to deal with complex disassembly of, you know, consumer waste? I mean, traditionally councils, you know, roads, lighting, and you know, the general amenity in your neighbourhood, and we've sort of, by default, they've become the managers of this whole complex waste stream. So that's got to change, and I think that with this new national waste management policy, which is covering packaging, end-of-life vehicles, as well as televisions, it's creating the framework, a regulatory framework in which for these industries to start to thrive, and they're out there. I mean, there are a number of firms which are actively involved in end-of-life processing of waste. A lot of it does go up to end up in landfills simply because of the logistics and the costs involved, but you know, it will change, and you know, from an industry conference I went to recently, I was reassured that there's a number of businesses out there who really see the opportunities in terms of, you know, turning this into a viable, profitable sector.
Before the e-technology, most appliances and devices seem to be more mechanical. And I've included in that the electrical, before electrical. So if I can take it back, for example, the horse and cart days, you know, and if a device usually failed, it was because a part failed, and that part could be easily replaced. But now we seem to have moved, particularly with the e-technology, whereby if a part fails, it seems that you can't, it's getting more difficult to find a part to replace in a device, and it's more economical to throw that whole device out and get a whole new one. You actually explain, because it's usually cheaper. But since in the last sort of 5 to 10 years, I've noticed that we're moving more towards the, if you like, the radio or the cordless technology, whereby we now have cordless telephones, cordless mouses, and Bluetooth. Now, if we move further into that technology, because there's going to be less moving parts and more products are not being able to disassemble, is that going to possibly slow down the rate of obsolescence in products, particularly as we move forward with the Bluetooth technology?
One of the things I talked about in my work was system independence, where you have one product that relies on another one. So if you get rid of that one won't work. So you end up living longer with the same thing. Computers, for instance, the printer works with that computer, that scanner works with that computer. As soon as you change something, it all gets upset. And of course, with things like wireless protocols, you know, Bluetooth, Zigbee, and many others, we are in a new world where devices talk to each other. And I mean, people speculate that this is the Web 3.0, Web cubed as they call it, where devices talk to each other instead of computers talking to each other. And perhaps if we move into that realm where things can self-diagnose or self-repair even, or even where something becomes redundant, another product can pick up that resource and supply it with that missing ingredient, whether wirelessly or otherwise. That could be, I mean, I think that's got a lot of exciting possibilities. And that's one thing we didn't talk about tonight, is that this whole Internet of Things and how that can be leveraged to extend lifespans. But yes, I mean, we've moved from a mechanical to electromechanical to a digital world. So yeah, the rules of engagement with obsolescence change, and we probably don't quite understand what those new rules are.
Is there a newer technology that is being looked at now, behind the scenes, by the electronic companies?
Oh gosh, I think there's probably numerous. I mean, I can't think of one in particular, but what we need to be very careful about is we need to disassociate what true innovation and technological opportunity is as opposed to just novelty. So for instance, the television argument again, 3D, LED backlight, I mean, yeah, they're all incremental novelty developments, and they have some use and need perhaps, but they're not fundamental and necessary for that ongoing utility or service that product could provide.
Just as an example, I was in New York earlier this year and I saw the latest television that Samsung are about to release, and it simply is a flat piece of glass that's only about 10 millimetres thick and no cables whatsoever. There's no visible cable. You can twist it, turn it around, it's on a simple stand, and the front and the back are exactly the same. There's no visible cables, and I assume that the glass simply illuminates through the equivalent of Bluetooth type technology. And that's an example, I think, where you can look at that and say, well, what possibly could go wrong, apart from in terms of obsolescence, that there will be a new stage of technology that may be invented in due course.
Yeah. Well, that might be great, but you'll only have that television for 5 years because of something being new 5 years later. Television ownership typically was 20 years, it's down to 5 years now. So even though we're buying the flat screens, we're not happy with that. We will want something again in a few years' time.
I'll take one more question.
Who was it?
No, you.
So you know the work of Pranav Mistry from the TED Talk? He's created the whole idea of eliminating objects altogether. And he has this one small camera where you can create your photos on the wall and do all sorts of things, and you actually don't need machines to help you do it. So that's a very interesting TED Talk that people can look at. But I wanted to see if you had any feedback on predicting how long that would take, because that TV sounded like a spin-off of one of his ideas.
Is this one of the things you wear around your neck?
Yeah, and it does everything.
Yes.
Thank you very much for a very clear talk. I think I learned so much about
Oh, thank you.
thinking about these issues. So thank you very much.